Hi there, my name is Artin, and today I will present my final project at Harvard University Extension School. The project is about neural style transfer for video content. So why I decided to go with this project? Creating cartoons is an expensive and time-consuming process. What if we could just take a video on our iPhone and create a cartoon-like video, utilizing neural style transfer technique? I believe it will boost the cartoon creation and the story visualization process. The project goal is to create a video based on the artwork. In this case, I took the artwork of my friend Natalia Lvova. The name of the artwork is The Village. And then on top of it, utilize the neural style transfer to extract the content of her artwork and apply that on the top of the video content. The steps that I plan to take for this video is the first, create the content video. Then on top of this content video, apply artwork style, which is in this case, it will be Natalia's village painting. Then compose video into the sequence of the images. Decompose it. And then store images in the content folder. Later, I will create a model, and for this project, I used VGG19, and I pre-trained that model with the ImageNet data. And as an optimizer, I used stochastic gradient descent. Then after model is trained, I will take all images from the earlier created folder and run those images through the created model. The output of that images, the new generated images, I will store in the new folder, and I will create a certain sequence by utilizing the naming order. And then eventually I will stitch all those images into a single video, those new generated videos. New generated images, sorry, into a single video. So the overall technologies that I used are, for the environment, I use Google Colab. For the programming language, I use Python. For the machine learning library, I use TensorFlow. As I said earlier, model is used by the VG19, and I pre-trained it with the ImageNet. For the image processing, I use the Pillow and CV2 libraries, and also I used a few other libraries like NumPy for the matrix processing, Matplotlib for the visualization, OS for the folders and file management, and so on. So a little bit about the video creation stats. So eventually, when I decompose my video, I ended up with the 284 images. And the reason why, because I used 10 images, 10 frames, which is images per second. Totally, when I was generating the video, I used about 100 iterations, like 100 epochs per frame. So total, I got like almost 30,000 epochs needed to run through to create this video. Again, model was a VG19, optimizer stochastic gradient descent. For the style layers, I used the low-level blocks, low-level convolutional layers, which I extracted from each block. And for the content layers, obviously, I went with the higher block and the higher convolutional layer. And for the weights, I also put the same weights for the style and the total weight, and a little bit lower weight for the content weight. Results can be seen in this video. It's a 2 minutes video that I also attached to the presentation. And as you can see, sorry. Yeah. So as you can see, this is the original video. I took this video from Lisbon in Portugal. The reason why I chose this video, because this video is rich with the lines. And now we'll see how the created video looks like. So this is the village painting that I've been mentioning before by Natalia Lvova. And this is the output video. As you can see, this video has this cartoonish, artistic look, which I think we can use in the future for the cartoon creation. So that was the video. What would be my next steps, right? I would like to create some sort of web interface to upload video and artwork, so kind of give it the access to the public, so people can upload their own videos and their own artworks and have the nice output video. Also, I would like to kind of create the preset artwork output options. And perhaps, I was playing with generative adversarial networks last, few weeks, and perhaps creating artwork using generative adversarial networks and then apply that artwork on top of the videos. I thought this is something could be pretty cool to play with. And the last but not least, last few days I also was kind of diving into the text extraction, like a text image extraction, and I think we can use that for creating more complex designs utilizing these techniques. So without any further ado, I would like to go over the code. So so this is the Google Colab file. Oh, there you go. This one is better. So this is the Google Colab file that I used in my for this project. As you can see, I exported a few libraries. Then the first block is about converting the video into the extracting frames from the video. And as you can see, I put 0.1 frame rate. It basically means that every 100 millisecond we will extract 1 frame. So total we will have 10 frames per second. And this is the code to extract the frames. And also, as you can see, we have a path and the style. I will talk about it later. But here we have a video capture. That's where the frames will be extracted from. So we have a function which does that for us, and we have a path content images, and eventually that's where we're gonna store every single extracted frame. And so if you'll take a look here, so you can see that all images been extracted, and obviously we kind of give them ordering numbers. So in this case, we preserve the order by the naming convention. And as you can see, total we extracted 284 images. Um, so second, so again, this is the style. This is just one of the images that I extracted from the content images folder, just to kind of give you like idea how the content and style images look like. The next block is about basically this is the all functions I put in the one block, and here I put like a detailed description of what each block does. For example, we have this like preprocess image function. So what it does is just take the image path, open it, resize it, and formatted image for the appropriate tensor. Pre-process it, right? It's self-explanatory. Then we have a deprocess image when we take actually the tensor and we reshape it and convert it into the image. So the pre-process is convert image to tensor, and deprocess is vice versa. We have a gram matrix function, and then we have like a 3 loss functions, which all of them we will, so this is obviously style loss function, content loss function, and total variation loss function. And then we process them through the compute loss function, which is called through the compute loss and gradients function. And compute loss and gradient function basically takes those functions and then adds them, compute loss takes all those functions, adds them up, compute the loss, total variational loss on top of all of them, and then for the compute loss and gradients, we basically calculate the gradient descent for it. And you can view here, and for the compute loss, I obviously added some comments to kind of distinguish each step along the way. Next block is the about the basically we want to weight all different components. So we want to make sure that like for example, we want to put more weight on the style image, or we want to put more weight on the content image, and here we can play, and if we put more weight, let's say, on the content image, then we will preserve more content versus we will preserve more style, and vice versa. Here we can see the line of the building the model itself, and we have a VG19, as I said multiple times before, and then we have a kind of outputting that, extracting features. Then we specify, again, for the style we're going to the lower level, for the content we're going to the higher level, that's why it's the block 5, and here we have block 1 and block 2. This is just to kind of, if you want to rerun it or retest it, you need to delete, but this is just, you don't need to even worry about it. And then the final loop, this is the main part of the program. We basically load data, we set up the dimensions, and we iterate. Like iterations in reality, it means that just epochs. So we just iterate through that, and from each every 100 iterations we create an image which we store in the results folder. And that's one of the results. As you can see, this is the original image, and this is the generated image. Generated image has this like wavy clouds, and like it looks like it was painted, not captured by camera, which was the goal. And yeah, and eventually we just convert all these images into the video, because we store all images in the results folder with the ordering in order. So you can select, we have 0001, 0002, so we kind of preserve the sequence in the naming, and then we just create the video using those images, and that's about it. You can see the final video over here, and you can have access to the Google Slides through this link. Well, I think that's about it. If you have any questions, feel free to ask, and appreciate. Bye bye.